Hey, welcome everybody. We're going to get started, and today we're going to change up over the last couple broadcasts. I've been doing more like just kind of, hey, let's figure out how to deploy X with CloudFormation and doing that one little kind of project and then stopping. So I thought over the next couple weeks we'd work for about an hour every Tuesday night, and I'd like to build out a web-based application. So nothing too serious. Virtual private cloud spread across a couple availability zones in a region, connected to the internet, load balancing, auto scaling groups for our web servers, shared file system with like EFS, and then maybe in the back end we'll put a database or something like that. CloudFront possibly, maybe even some Elastic cache, just sort of depending on if we get some feedback on direction and where people would like to go, we'll handle it that way. All right, so I think today we're going to concentrate on building out the virtual private cloud. So the first thing I always like to do is decide on the range, IP range we're going to use, leave a little bit of space, because as much as we always like to think we're planning everything out perfectly, a lot of times something will change in the future and now we need more IP space. We want to add a new subnet or something like that. So I tend just to use a really simple web-based app here, and I already got it set up with my range. I'm going to use a /16 just to make it easy on us. Obviously we want to use ranges that make sense, but I'm just going to divide this across, we'll make it the math easy again. We'll divide it across 3 availability zones in theory. So, or sorry, 4 availability zones, even though we're not going to use all those. We're going to use 2 availability zones, and then this will give us some space if we needed to stand up across additional AZs later on. So I think what I'm going to do is we'll create, we'll use the 16 as our VPC, and then we'll slice into these AZs and we'll break these down into just a simple public and private subnet. Okay. And the very first thing we're going to do is define our VPC. We're going to do everything in CloudFormation. We write in YAML. All the templates that we create are YAML, so we'll continue to do that. And let's start building, okay? So I've got my editor open here, and I've got our project all ready to go. So I'm just going to create my first YAML file. We'll give it a description here. All right, I'm going to just put a placeholder in right now for parameters. We'll have some parameters here at some point. Actually, you know what? Because we always do this, let's start with this. We tend to use a standard set of tags. So let's build these in now. So those are the tags that we usually create for all the templates that we're building. And who owns the resources, who owns the template, how do we contact that person, and then just as an example, the environment setup. So is this in production, is it development? We're using here some control mechanisms. So if I'm deploying this through the management console, I get a drop-down list, and it must be either development or production. So this is a nice way if you're providing these templates to somebody, you're not running them yourselves, then it's a good way to increase the likelihood of that template being deployed successfully, the stack being deployed, and you getting the resources. So there's all sorts of additional functionality we can add here, but for the time being, we're just going to keep it simple and use allowed values. Very first thing we need is our VPC. Okay. And in all of these setups, what you'll notice is there's a series of attributes or properties that we have to define. Some of these will be required, some of them are optional. So we're going to have a look here and see what we need. So the first thing is, obviously we need to find our CIDR block, so I'll just grab that. And I'm going to use another attribute here. I'm going to use the reference attribute. This allows us to basically like variables. So I'm just going to say this is our VPC CIDR. And we'll go back up here. I'm just going to do something like this. So these are our tags. And then we'll put up here VPC CIDR. This is a string, and we'll also provide it that default value. So that's from our editor earlier on. So our VPC now, essentially when we execute this, this becomes the parameter. Basically think of a parameter as a variable as an input. The CIDR block will get populated with that, right? So this is an intrinsic function called reference, and we're referring back to this parameter that we've defined. If we look at the rest of this, enabling DNS host names is there by default. We don't have to worry about that. So is DNS support. Tenancy we're going to leave in the default setting, which means we're going to run in shared hardware. If you were in a situation where compliance requirements or something like that wouldn't, or it doesn't allow you to run in a shared environment, then you could deploy your VPC as a dedicated VPC, a dedicated instance tenancy, and then you're going to see here that any instances by default are launched as dedicated instances. So there's additional costs for this, and for what we're doing, it doesn't matter. And then tags. So essentially all we need to do to define our VPC is give it the CIDR range and provide it. Actually, that's all we need to do, right? Now we tag this because I want to be able to remember this stuff later on. And this is where we're going to refer back here to the parameters that we created earlier on. And what did I say? Environment. Okay. So that's basically metadata that we're going to associate to the VPC that we create. Simple as that. The other thing that I like to do here is give it a name. So always capital. And we're going to actually use another intrinsic function here called sub. And this allows us to create more, like I could just do something like this, but it's hard coded, right? And one of the things that we always try to do when we're building out these templates is create the most flexible templates that we can. We want these templates to be able to run across AWS accounts, across AWS regions, potentially even across multiple customers. So we always like to keep them as dynamic as possible. So we're going to use sub, and then we're going to pass in a pseudo parameter. Okay. Pseudo parameter are built-in functions from AWS. So in this case, what we're going to do is we're going to populate this with the name of the stack, and then maybe what we'll do is go like, how do I want to do this? We'll go, I can never remember this, if it's like, okay, we'll try that and see what it does. So essentially what we've done here is just define that virtual private cloud. Okay, step one. And what I like to do now is, before we get too far along, we're actually going to set up our deployment script for this. So I've got a bit of a framework here that we use kind of as our general way to work with. We use GitLab for everything. So we're creating a deployment script within GitLab, a GitLab CI. And I just grabbed a couple cheats out of an earlier template that we had, so I didn't have to remember all this. So we've got the validation phase. What we're going to do is run a CloudFormation CLI command, and we're simply going to validate that the structure of the template is correct. This isn't going to actually make sure our environment variables are correct, or parameters, anything like that. It simply is going to say structurally the template is sound. Okay. And then we'll do a deploy. So I'm going to, yeah, let's just overwrite this. So we're going to call this, our VPC deploy. We'll give it a name. In this case, we're just going to do, let's do this same thing. Okay. We're going to pass in a variable, which I don't, yeah, okay. So I've got it set up here. We'll redefine that as development so it matches up with what's in our template. So I kind of like to think of these as, I call them global variables, and these would be like stage variables. So this stack name variable applies only to this stage. And then again, we're using a few different CloudFormation CLI commands. So we're going to deploy our template here, which is actually VPC YAML. Stack name is set here. Then we've got some other pieces of information here. So we're going to tag the resources within the account, but we're also going to tag the stack itself. So we need to set these up, and they've got them up here already. So I think we're good. Okay. We don't need capabilities IAM because we're not deploying any IAM resources in the stack. And then the profile here is essentially just how we're connecting to the AWS account. So in our case, we're going to use our demo account to deploy this. We're going to wait for the stack to exist, and then we're going to enable termination protection on that stack. So in theory, what we have now, as long as I don't have any typos anywhere, and we need to get this, is a really simple CI script. Validate the template just using CloudFormation validate template, and then deploy it. Okay, so let's try this. We're going to check this in. And we'll jump over here, and I've got our project all set up already. And did it already fail on me? Okay, let's have a look. Not sure if that's when I set it up for testing or not. Let's just reload. Yeah, okay, that was just my test earlier. So there we go. Okay, our validate worked, our deploy worked, which means if we go back here into the formation service, get rid of our filter from earlier, there's our development VPC. Okay, we've got a couple other things here. We're gonna actually, while we're waiting, let's just delete this. We don't need that. And what we've done is we've generated a stack set. So a stack set, think of it as like a dry run. What it allows us to do is, sorry, I said stack set, I meant change set. What it allows us to do is essentially CloudFormation will simulate the deployment, and it doesn't necessarily, it's not necessarily important on the very first deploy, but we would use this all the time because this is really important. It basically tells us if we execute this template, what will happen. So we're going to add a logical ID called VPC, and it's a VPC. Okay? And as we start building this out, you'll see kind of why change sets are important. It gives you an opportunity to understand what the effects of deploying an update to a stack would be, and it also gives you the ability to separate duties. Like, so I might be creating the stack, creating the templates, and somebody else is responsible for deploying them. So it gives you that as well. So we're going to execute this. And really quickly, because it's just essentially an empty VPC, this should come to life pretty quick. So what we're going to do is open up another tab, go to the VPC console, and we should see that VPC here already. Okay, there it is. Okay. If we have a look at the tags, these are set by AWS. So you can see any tag that's prefixed with AWS colon is assigned by AWS. So you can't change these. You can't really do anything to them. Here are the tags that we set in our template. Okay, so if I refresh this, yeah, the name isn't great because we can fix that. Okay. If we go back here now, we've got to create complete. So there's our first step. We've just got that really simple VPC skeleton. Okay. I don't actually need this because the stack name is VPC development. So that's probably enough. Maybe what we want to do though is maybe add another tag in here. Let's go like this instead. Okay. And we could do something like this. What do I call it? Just app, right? We'll come back and see if that works in a minute. So now the way that I normally like to do this is think about all of the other components that we need to make this a functioning VPC. We want this VPC to be available to the internet, so we need an internet gateway. So I'm just going to put some placeholders here. Okay, so an internet gateway is the way that we connect our network to the outside world. I mentioned already that we're going to create public and private subnets. All our resources will actually sit in the private subnets, meaning they don't have any direct access from the internet. But we know that those web servers are going to need access to the internet for patching and things like that. So the way that those resources get to the outside world is either through a NAT instance or a NAT gateway. We're going to use a NAT gateway because they're managed by AWS, and we need actually 2 of these. Okay, 1 for each of the availability zones that we're going to use. Part of the NAT gateways, we'll do this here, 2 times NAT elastic IPs. So the NAT gateways we're going to deploy are going to be in the public subnets that we're going to create here, and then they also need to have public IP addresses. And that's how they're going to get out to the world. Okay. We need subnets, so we're going to say 2 times public, and then we'll say 2 times private. Okay. We also need route tables, and we're going to do the same thing. We're going to say 2 public route tables, 2 private route tables. What I like to do is create a route table for every subnet. That'll give us the most flexibility that we can get here. So we could end up with individual route tables or individual routes. Like you might want to have traffic in one subnet be handled differently than another subnet. So this gives us the most flexibility. Okay, and then we basically need some routes, and I'll just call this public. Okay, and we'll call it private. Off the top of my head, I think that's really all we need for the time being. As I build this out, I might think of a couple other things, but we'll start there and just see how far this gets us. Okay. So the first thing is we need to create our internet gateway. Okay, this is another super, I can't remember if it's VPC or EC2, so let's go back and have a look at the doc. Yeah, here it is. Okay, so it's EC2 Internet Gateway. One of the things that you have to remember in CloudFormation is that by default, CloudFormation will try to deploy everything in parallel. Makes a lot of sense because as your templates get larger, you want those resources to be deployed, let's say, efficiently, right? So by deploying them in parallel, we can push everything out, in chunks and batches. But we necessarily don't want that to happen. In some cases, we want to control the order in which things happen. So Amazon has provided us with a few different ways to control this. One of the easiest ways is just to say depends on. So what we're saying here is deploy the internet gateway, but in order to deploy that internet gateway, the VPC has to be there first. We just want to ensure that that VPC is there. Okay. Oh, hey, Kevin. Thanks for hanging out with me. Okay. Pretty simple, right? And now we can get to defining the properties for this. And if we go back, literally there's nothing to define here. There's nothing to define because the internet gateway is fully managed, right? It's highly available, it's fault tolerant. All we really need to do is set up our defaults. I'm going to steal these. Okay. Fix the spacing. And what we'll do is this will be VPC development, which as I say it out loud, I don't like that. So let's do this, right? This will be VPC development, but I don't want to call it app again. I just want to call it IGW. Okay, so our internet gateway. What we've got now is if we were to deploy this, a VPC connected to the outside world, but we really don't have any routing or anything set up. So let's create our NAT gateways. Okay. The way that I like to do this is just say NAT EIP 0, and these are going to look exactly the same. So I'm just going to create the placeholder. Need to look it up again. It's just, I think it's EC2 EIP right there. And here's what we need to define. So just like we did before, what's required, what isn't. So a domain, are we going to use this in a VPC or a classic deployment? unless you have an insanely old AWS account, you wouldn't deploy anything in Classic anymore. I don't even know if you can anymore, right? So it's pretty much locked down. So VPC is the default now. I normally wouldn't put this in anything. We're not going to worry about an instance ID. We're going to come back to this when we create the gateway. We don't have to worry about the pool. We have to just tag it again, right? Best practice is to tag it. Oh, hey, Gold Zulu, you're here as well. Yeah, man, we hand code everything. Okay. We're not. I'm not a huge fan of CDK at this point, so I'm sure it'll come along. But I've been writing CloudFormation templates for so long. This is just like, it's just I joke with people that I dream about CloudFormation templates. So I think today I spent pretty much half my day writing CloudFormation templates. So it's just kind of what we do. All right. So all we need here is default. Okay, if the region supports EC2 Classic, the default is standard. Otherwise, the default is VPC. I'm not quite sure if my region supports EC2 Classic, so I'm going to be careful with this one, and I'm just going to say EC2 EIP, and we're going to say properties, and it's just domain. We're going to set it to VPC, just to be safe, right? And then we're going to do same thing here, grab those. Okay, and we'll just call this EIP0. And you know what I'm going to do? I'm just going to grab all of this and jam it in here. Fix the weird spacing. All right. And now what we need is we need the actual NAT gateways that are going to be associated to these. So the NAT gateway is a little more involved, but not really. Okay, so you can see basically what we need to do here. The allocation ID is how we associate that elastic IP to the NAT gateway, and then we need to put it in a subnet. So we're not going to be actually able to create everything in this NAT gateway yet. I'll show you kind of my placeholders that I use, and then we'll go from there. Yeah, Gold Zulu, we're creating a web-based. I kind of decided that normally we do very specific solutions. Like we'll just say, hey, here's how you deploy a secure S3 bucket. And I thought over the next couple weeks, we'll deploy a web-based workload. So VPC, subnetting, load balancing, auto-scaling groups, security groups, all that kind of stuff. So we'll build out kind of more of a project. You could use it for, we would use this for like content management systems if we're building those out for customers or something like that. The beauty of CloudFormation is once we build these templates, if we build them in a way that's flexible, we can use these multiple times, right? So I normally, like I'm using this as an opportunity to basically just show what the process looks like. Like if we're building this for a customer, I would say 98% of this is already built and it sits in a GitLab repo that we use for all these projects. Okay. So yeah, all we need, allocation ID. So let's do this. We'll say, I'll call this NAT Gateway 0. Was it EC2 again? Yeah, EC2 NAT Gateway. Oh, we're going to do depends on here again because we need a couple things. We're going to need the NAT EIP 0 to be there. And we're going to need something that we don't have yet. We're going to come back to this one. So we'll say properties. And all we needed was allocation ID, right? Yeah, and that is going to refer to NAT EIP 0. Okay. The other thing we need is a subnet ID, yeah. And we're going to say, I'm going to use my ever sophisticated placeholder. So later on, if I ever wanted to go back and make sure that I got all my placeholders filled out, I do a really sophisticated find for that character string, and then I can find what I'm looking for. And then we needed tags. So no surprise here. Do the same thing. And we'll call this, we'll just call this NAT GW0. Okay. And we're just going to duplicate this because we want the same thing. in our other subnet. So this is all going to be just changed to ones, right? The other thing that we need is we need a subnet to put these in. Okay. Is that valid? Absolutely not. But later I can do this, right? And it'll just highlights everything for me. It's just a little thing I've done for a long time. So now I can find, I'll often do this if I build a big template and I had a bunch of placeholders that I wasn't quite sure what I wanted to do with. I'll put those in and search for them, right? I think, you know, a lot of times you'd see, do this, right? We could do this as well. Maybe this is a better way to do it. Okay. Actually, let's go like this. It might look a little nicer too, right? We'll do that. It's actually stands out. It's easy to see too. All right. There we go. A little easier maybe. What these NAT gateways need are our subnets. So we're going to create our first 2 subnets. Okay. I always forget. It might be VPC, might be EC2. Let's go have a look. Yeah, here it is. Okay, EC2 again. Okay. So what do we need? We're not going to worry about IP6, so we're not going to worry about that. We are going to assign this to an availability zone. We will have to provide it with a CIDR block. We'll come back to this value here. We'll talk a little bit about that. Associate it with a VPC and tag it. Okay, so what we want to do now is go back to here and think about our subdividing. So really what I want is I want a /18 network for each of the availability zones, even though I'm only going to use 2. And that way it gives me lots of space later on. So I'm just going to change this and make it 18. Okay, because that'll be kind of in AZ1 or AZA. That's what I want to reserve. And then what we'll do is normally what we would say is create very large public subnet or very large private subnets and really small public subnets, because you really aren't going to have a lot of resources in those public subnets anyways, like load balancers, NAT gateways, things like that. But for the most part, we're going to put everything in that private subnet that we talked about. I'm going to do this the easy way, and we're going to consider a 4,000 IP range subnet to be small. But if we were doing this for a customer, we would make this much, much smaller than this. But just to keep the math easy today, we're going to make our public subnet that guy. So what we're going to do is we're going to go back to the top and go here and say subnet 0 is that. Okay. Subnet 1 will be our other public subnet. And we'll use that same thing here, right? Add CIDR range. And maybe we'll do this instead. I think that's too generic that I'll forget what they are later. So we'll go public subnet 0, public subnet 1. Okay. And then down here, let's do the same thing. Public subnet 0. And we'll go back here and see what we need. Don't care about that. We'll come back to this guy. Okay, I'll come back and tell you what that is in a minute here. We need our CIDR block, which we know we're going to refer to. Okay. Now, I mentioned this guy before. When you create your subnets, you define whether or not you want a public IP address to be assigned to the resources in that subnet, like if I create this public subnet, and let's say that I enable map public IP on launch. If I create an EC2 instance in there, it will automatically get a public IP. I don't want that. So I'm going to actually do this and make this false. Okay, so this means that if I launch something in here, I would have to go back and assign an IP address to it. It's not going to get a public IP. Okay. Tags and then VPC ID. So this here will refer to VPC 0. We created that already. So here's another example of where we would add a depends on. Make sure that VPC, that logical resource, the VPC 0 resource that we created earlier, is already there. Okay. Now this, we could take the easy way and do something like this. The problem is that if I wanted to use this template anywhere else, if I was running it outside of the CA Central region, this wouldn't work, right? Because there wouldn't be an availability zone called CA Central-1. So what we're going to do is we're going to use a select statement here. And I have to try to remember what this is. I'm hoping that we can find an example of it. Okay, so this is the short form that we're going to use. Essentially, we're going to say select the first record in the index, 0, of all of the availability zones in the region where we're going to deploy. Yeah, I know. I haven't memorized this one. I haven't written enough of these yet. So I'm hoping it's going to look very similar to this. So we're going to steal this to start. Okay. And I'm a little weird about the spacing, so we're going to tighten that spacing up a bit. Right here. See this? So we're actually going to use multiple intrinsic functions. So this getAzs basically is going to give us a list of all the availability zones in this region. So we're going to steal this and we're going to replace right here. Okay. That doesn't look right to me. I think we can shorten this, but I cannot remember what it is. I'm going to run it like this and see what happens. So essentially what we're doing is we're running the select intrinsic function, looking for the first entry in the index of another intrinsic function called getAzs, and getAzs, we're passing into it the region where we're running. So this will essentially pass an index back to CloudFormation for all of the availability zones in the region where we're working. In this case, CA Central 1. Okay. And we need tags. Tags. Always tag. Okay. And we'll just call this pub subnet 0. And we're going to grab all of this. And we're going to do it like this. All right. So I think what I'll do is I'm gonna check this in and see what happens. I would suspect that I probably have an error here somewhere, right? There's a lot of code that we've changed. I'm not convinced that this is exactly the way I would do it, but it kind of looks like what was in that sample. So let's see. Oh, we got oh yeah, oops. All right, this will absolutely fail. So this needs to also, public subnet 0 has to be there. And we can refer to public subnet 0 to get its actual ID, right? Its logical ID. And then we want to do the same thing here. So we're going to say public subnet 1, and we'll do the same thing. All right. Let's deploy this and see what happens. Oh, did you see that? It gave me a warning. Hold on, let's check something. Yeah, here we go. I forgot about this guy. There's a good reason to use those to-do statements, Goldzuda, right? The editor, I'm using PyCharm. saw that and said, are you sure you want to check this in because you've got a to-do statement? I like that. So if we go back to here, and I'll change this back to 16 and just subdivide it a bunch of times. This is the range that we want to use in the other AZ. So I'm going to say 1098 64 18 update, and we're going to do the same thing. Okay, we'll leave the private subnet large and this smaller. So that's the range that we need for that other value right here. Okay, so now let's deploy this again and see what happens. All right, no warnings at least about to-dos, right? So now what we can do is the first thing that, so I mentioned already that we deploy everything through GitLab and we create simple CI scripts, so I know I've got an error. Right. So the validation script failed, and here's the error. Must be a string, received a map instead. I knew that didn't look right. So that is, if we go back here, that is, where is it now? Right here. It's how I've got this structured. I want to say I'm mixing, I'm going to try this from memory. That still doesn't look right. Yeah, see, they don't give you a good example. So you don't want to do this. It works, but it's not the right way to do it, because if you try to deploy this somewhere else, it's going to fail. So I've got to remember. I definitely have this written somewhere else, so hold on a sec. So Gold Zulu, like this is a template that we've pre-built, right? Ah, see? That's what I want right there. Way nicer. So let's go back. Where was I? PyCharm. Go here. And we're just going to nuke this. That's way nicer, right? I knew it, just looking at that, it didn't seem right. So this we have to change to 0. Okay. Let's try it again. Hey, as I'm waiting for this to go, have you guys, either of you guys tried Bespoken? I know Jeff mentioned it a couple times, and I think he uses it for his testing of his skills. Have you tried it out at all? Kevin or Gold Zulu? Yeah, I really like it. I'm trying to rewrite a skill right now, and a really nice way to do like local testing and stuff like that. I guess it's not local testing. Essentially what happens is it creates for you a link, like an HTTPS link, and then you go into Alexa Developer and you plug in, you change the endpoint for the skill to that proxy URL it gives you, and then you can script everything. I can like still run in the developer and ask Alexa the different, to test my intents and stuff. And then on top of that, you can create all sorts of test suites that you can run through. Pretty slick. Okay. All right, so we got another error. All resources and parameters must have unique names. Common name, public subnet, public subnet. What did I miss here? Public subnet 0, public subnet 1. I wonder if it doesn't like the fact that I've got... yeah, I don't use VS Code. So I'm using it PyCharm still for everything. Maybe I need to switch to VS Code. I wonder if I should change this to... Let's do this. Public... Let's do... we'll do that instead. It's a little long, but it'll do the trick. I don't know if it doesn't like the fact that those names are the same. Okay, so we've got that there, and we need to change this one, right? I'm just going to make that one change and see if it complains about the same issue. Yeah, I spend most of my time writing Python stuff. Like if we're writing Lambda functions or anything like that, it's almost exclusively in Python. Although, because I've been watching Jeff, I'm like thinking about, at least for the voice skills, looking at Node.js. Yeah, I've heard other people talk about ngrok, but I've never tried it myself, so I'm not sure. All right, so let's see. We've got another failure. If it's the same issue, then I know it wasn't my names, so I've got a duplicate. Unrecognized resource type. Oh, that's EC2 subnet, right? I even looked that up and still typed it wrong. I'm sure I like the MIDI in the background. Oh, okay, there we go. Didn't fail right away. So that's a good sign. So essentially what should happen is it's going to generate another change set for us. And it's going to basically simulate, if we execute the change set, what would it do? Okay, so we're going to go have a look. Here's our development VPC. We can go look at a new change set. And you can see these are all the things that are going to change. Okay. Essentially, a whole bunch of other resources are going to get added. But we did modify, remember, the name tag, I think it was, on the VPC. So this is why it's important if we're using this. So we use CloudFormation for everything. I see here that it's modifying a resource, but it's not going to replace that resource. So this is really important. Okay. Execute. We use GitLab for everything. Did I say GitHub? I'm not sure what I said. We use GitLab. Self-hosted GitLab. We had a customer that used it. And we used to use GitHub, and we had a customer that used GitLab, and we just really liked it and kind of stole some ideas from them on how they were building out certain things. So ever since then, we're using GitLab for everything. All right, so we got a failure here. Look it, I typed something wrong. Yeah, I can't spell availability zone. Let's try this again. Availability zone. Before I push that, I'm going to see this here, cleanup in progress. If I push this too quickly, yeah, I do need Grammarly. Yeah, mostly GitLab, mostly because of CI. It just really, it's easy and it's really powerful, right? Like the CI scripts that I'm showing you here are super simple. So I got to wait for this to actually say that the cleanup is complete. Otherwise, if I push that, it'll fail because it'll say it's already, like it's in progress and can't be changed. So we'll try it again here. It's funny that you mentioned Grammarly. I run Grammarly for everything, right? They need a Grammarly for CloudFormation. right, let's try this again. See if we got any other spelling mistakes here. Okay, this is hopefully a little better. Yeah, there is probably a I know that there's a CloudFormation extension, and I used to use it. Oh man, is malformed. Okay, that's an interesting one. I think I'm passing the wrong. Remember how we did the allocation ID? This is actually a good example of where you've got to read the docs. So if I go back here and look at Elastic IP, all the resources that you're going to create, they have this return values. So I want, for the NAT gateway, if I look at the allocation ID, I want the allocation ID of the Elastic IP. Okay, so I'm missing something here. Yeah, see, it might be this. I think I need an intermediate step between the NAT gateway and the Elastic IP. I can't remember this part. Okay, we're gonna cheat because I don't want to get too bogged down here. Did I leave that file open? I didn't. Oh, there's something else we forgot. I'll come back to that. So there's the definition. Depends on the IGW. VPC. How do we allocate it here? See right here? All right. Get the allocation ID. I just referred to I did a reference to the logical resource name, which won't work. Because if you look here, what's this saying? NAT IP allocation ID. Yeah, okay, so Elastic IP. So if we go here, and we look at the return values right here, the ID that assigns to represent the allocation of the IP address within the VPC. So we need to change here. Okay. And I noticed in there that we forgot, when you create the internet gateway, actually, let me show you this, okay, before we deploy it again. Watch this. So this is going to be, I think this wouldn't work. If I got the EIPs going, I don't think it would work, because if we filter here on the VPC, okay, try that again. There's the VPC that we've created, bad name, but it works. And then if we look at the internet gateways, it's attached. I was expecting not to see that attached. There we go. That's bad caching. So we've created the internet gateway, but it's not attached to the actual VPC. So we've got to fix that. Back over here. There's the internet gateway. What if they give us a sample here? No, they don't. Here it is. EC2 VPC gateway attachment. I definitely will spell that wrong, so let's just go like this. This depends on the internet gateway being there. Change that one up. All right, so we need internet gateway. So in this case, we can refer to the IGW that we created. We also need to get the VPC, so we're going to say ref to the VPC 0. So we're going to add that up here too. And in this case, the virtual gateway. So in this case, we're using the internet gateway. We don't have a VPN gateway. We're not connecting back to our on-prem environment, so we're going to leave that where it is. Okay, so that should fix that missing piece. And I've changed the allocation IDs here. So let's repush this and see what happens. Okay. All right, maybe third time's a charm here. Let's see what happens. Didn't fail right away, so that's a good sign. Oh man, what have we missed? I keep spelling things wrong. Internet gate. I think it's supposed to be internet gateway ID. Yeah. Yeah, yeah. And this is why, like, you know, we build these types of things, and then once you kind of have it in the repository of all the templates, you know, we're doing this more as just a learning exercise. Then you can just blast these things out all over the place. I'll show you in a second here. Once we actually get this to run, I'll show you what you can do. Okay, same thing. All right, there we go. So we got our Elastic IPs now for the gateways. Gateways are coming to life. The attachment is happening. I think we got the spelling mistakes out of the way. So if we go back over here now and we look at, let's do the filter again. So there's our new VPC subnets coming to life, right? There's the CIDR ranges that we assigned. We look at the internet gateway. It's now associated. So that means in theory, we have traffic to the internet. And then we've got, there's the NAT gateways coming to life. So we're good at this point, I think. I'll show you what I mean. Like once we get these templates built, we could just do something like, if we go back to here, right? Let's say, you know, you could say deploy to CA Central right? One region. But let's say you wanted this same thing in another region. I could just do this and say, let's go US East 1. I'm just going to call this temp because we won't leave it. We'll leave it in the same stage. We'll leave it here. Actually, let's do this because I think... No, we'll leave the stack like that. All I need to do down here now is CloudFormation. I want to override the region that's passed in that profile. So I'll just do this. Okay. We'll leave that for a second and see if this is done. So we got one gateway up, the attachment's up. Okay, so we're just waiting for this second gateway to come to life. There we go. Okay, so we've got that thing work now. So in theory though, what we could do, I'll just show you this quickly. All we did was add a new deploy stage, or a new deployment job, really. So I think this is where like infrastructure as code in general becomes important, right? So if I go back over here and go to CA Central 1, or sorry, US East 1, we'll give it a sec. There we go. There's the change set. And what I would do here if I executed this is it would create essentially the exact same VPC. Now, the one gotcha with this is you don't want overlapping CIDRs, the ranges in those VPCs, otherwise we can't route traffic, at least easily. So you want to make sure that we would change that normally, but you know, for demonstrating like this, it's super easy, right? What is the image for the EC2? So you're talking about an Amazon machine image, an AMI? Think of an AMI as like, remember in the old days, you mentioned Gold Zulu, the data center? You used to have somebody would keep those CDs, right? And the CD would be an image of a machine that you had to build, like a database or something like that. You plug that in and away you go. That would turn it into it. Oh, for this form, I haven't made it that far yet. My goal for tonight is really just to get the VPC up and running. That's it. But when we get far enough along, I'll show you the AMI. I'm just going to use the native AWS Linux 2 one, and then we're going to install some agents and things like that on it. Okay, so nothing fancy. Okay. All right, so I'm in Northern Virginia. I don't want to put this here, so I'm just going to delete this stack. Get rid of that. And then we'll just nuke this so we don't end up with duplication. Okay. So now we've got our public subnets, NAT gateways. We don't have any route tables or anything like that, so we'll figure those out in a second. But what we're going to do is we're going to take these two definitions, and these are going to become our two private subnets. Okay, because they can look exactly the same. We'll just change some names and stuff like that. So this private subnet 1, that stays the same. We'll create this. Okay, and we'll just call this. Okay. So if we go back to the top, set up some more parameters. I'm just going to do that. I'm going to revert to my bad habit because we're going to fix this right away. Okay, so let's go back to our editor over here. And we said we're going to use a /19, a larger one. And this is in 64, so that would be this guy. we take this same... I should write this down when I do it so I don't have to keep going back and doing this, but this is easy. So it's 18 we created. And then we want to do this, so that will be the range we'll use for here. Okay. So that should be private subnet 0, private subnet 1. So let's deploy this one again really quickly so that we just validate that that works. Whoops. All right. So that should go pretty quickly. When are you guys broadcasting next? Gold Zulu, I probably can't watch you live because I think you broadcast at weird times. Because I'm in the Eastern time zone. But Kevin, I think you're in my time zone or you're pretty close to me, aren't you? Oh, okay. Yeah, Justin's broadcasting. All right, so there. That means now if we go here and we look at our subnets, 2 private, 2 public, there's the ranges, right? Smaller public subnets. Yeah, sorry, public subnets, larger private subnets, and you can see we've spread them across multiple availability zones, so we're good. Okay. 2-3 hours ago normally, so 8 p.m. or 10 p.m. Yeah, I'm trying to do Tuesday 7 p.m. Eastern, kind of like finish up dinner and and then jump here. Oh, Gold Zulu's gonna, or sorry, Giorgio's gonna be broadcasting soon. I think I'm probably gonna finish up in about 20 minutes maybe. So maybe I'll jump over to his stream and see what he's up to. All right, so subnets are there. That's all good. What we need is the route tables. We're going to create a route table for each of the subnets, and then we're going to set the default routes. And this is going to be really easy. The default route for the public subnets will be the Internet Gateway, the IGW that we created earlier, and the default route for the private subnets will be the NAT Gateways. Pretty simple. So we're going to do public. We'll shorten this route table 0, and I got to look these up. So we're creating a route table, right? Super easy. VPC ID. So just to, oh, I didn't do that right, did I? I gotta say type AWS EC2 route table. And just to keep the depends on thing going, we're gonna say VPC 0. Okay, EC2 route table, and then we'll grab all this. And we'll call this, call it pub route table 0. Okay. Easy, in theory. It's about 50 minutes. Okay. Yeah, I'm gonna jump over there and see. I haven't tuned in from for his stream for a while, so maybe I'll do that tonight when I'm done here. Okay, the rest of this is again the same. type. Oh, you know what? I don't have this. That's not going to work. Properties is important. So let's change that to private route table. I'm going to do the same up here. All right, there we go. And then create this one. Okay. I think I'll do the same thing. We'll just push this again and make sure that I don't have any typos or anything like that. So we've got, if this works, we've got the route tables, but those route tables aren't associated to anything. So we have to associate the route tables to correct subnets and then add the routes. Okay. And then at that point, we have the framework for our VPC. So that worked. Let's go back over here and see the change set. There we go. There's our 4 route tables. That was an easy one. So if we go back here, we still have the filter on. There's the 4 route tables. You'll notice this one here. This is the main or the default route table. So every VPC that you create will have a main route table. And if we highlight this, if we look at the subnets, all of the subnets that we've created are associated to that. So it's kind of like a catch-all. But as I mentioned earlier, we want to have individual route tables for every subnet. So we're going to now change the association and push these subnets into those route tables. Okay. So there we go. We'll do this. We'll call this route table associations. Is it VPC? It's not. Oh, there it is. Okay. So you can see what we need here. The ID of the route table and then the ID of the subnet. And I'm not going to try to type that based on my my experience earlier tonight. So we'll say pub0 association. And this depends on a couple things, right? So we called this public route table 0 and subnet 0. And we'll just do the same thing. We're going to copy these. Ref, what did I call it? Pub table 0. And then I think it's just subnet too. Subnet ID. And we called those what? We didn't call it subnet 0. I think we called it public subnet 0, didn't we? Yeah, so there's, yeah, we spelt it out. So we'll fix that. All right, so let's push that again. See how that goes. So let's see if we've got all this error free, no typos. So if this works, what we should see in the console that we were just in is all of the main route table should be empty now, because we're associating the subnets with their route tables, right? Their own route tables. So if we go here now and refresh this, subnet associations in our main route table are 0 now, right? Nothing's here. If we look at this, we'll have a single, if I make this a little larger so we can see it, right? Private subnet, public subnet, public subnet. Now there's no routes here. So essentially we have the ability to route traffic within the VPC across the public subnets, the private subnets, but nowhere else. So now what we need to do is we need to set up those default routes. We need, we're basically going to create individual routes for each of the route tables. So we're going to say public route 0. Okay, does this depend on anything? Yeah, it depends on pub, what did we call it? Route table 0. Go back here. Here's the route. You can see we've actually got a fair amount of stuff to do here. So what we want to say is basically the default route. I'm not going to try to type that. So we say the destination CIDR block. If you're basically trying to go anywhere, right? If you're trying to get outside of the VPC, this is the way that we want you to go. Okay. In this case, we want to route that traffic because it's a public subnet. We want to route it to, is it the gateway ID? Yeah, the gateway ID refers to the internet gateway or a virtual gateway. So we want this. And we're going to say ref IGW0. And like we've done throughout here, just to make sure, we'll do that. Okay. What else do we have here? These are all just the different places we can route, and we have to associate this route to a route table now. And again, it's the ID. So we'll say we want this to go to, oh, I already got that. And just like we've done before, we're going to grab all this. Change that. And then we need the route tables for, or sorry, not the route tables, the routes. This is going to look a little different, but I'm going to grab this anyways because it's going to be almost the same. Okay, so this depends on private route table 0. The destination block will still be 0, right? If you're trying to get anywhere, this is the path you want to go. But we're not going to go to the internet gateway. We're going to look at the NAT gateways. So we have to change this, and this refers to NAT. I don't remember what we called it. It was just GW? Yeah, I made it caps. Ugh. So NAT GW 0. And this will be private route table 0. All right. Just make sure that none of the validation fails. Ah, there we go. Okay, an error. What do we do? Oh, spelling mistake. Pub route table 1. Right there. Now, did I copy that? No, those are good. Those are good. I'd fail that quick. Ah. There we go. Good. So if we go here, we should have a change set and 4 routes to add. So let's execute that. Perfect. So now if we go here, we look at these route tables. I have to refresh. There we go. So you can see the private route tables, its default route points to the NAT gateway. They should both look like that, but they're pointing to the NAT gateway that we deployed in each of the availability zones. That way I kind of, in my brain, I kind of look at it or think about it as like a chimney, right? I want the traffic, unless there's an issue within the global infrastructure in AWS, I want the traffic to kind of head north-south or in a chimney, right? So straight up and down. So I've got that set up for a NAT gateway in AZ A, a NAT gateway in AZ B, and that routes the traffic. And then I've got in the public route tables, you can see in this case, they both point to the internet gateway. So at this point, we've got, oh, great, Kevin, I'm glad it's making sense. All right. So at this point, I think I'm going to call it a night. We've got the VPC built, the subnets, all the routing. So in theory, if we were to deploy like an EC2 instance or something like that, then it would have internet access, whether we put it in a private subnet, a public subnet, wherever we threw it. Okay. So I think that's it for tonight. Thanks folks for hanging out with me for a bit. I appreciate it. And we'll be back next Tuesday to continue building this out. Kevin Gold, I'll probably see you guys in Discord anyways. Enjoy your evening, folks. See you later.